So today we're going to be learning about vectors,
Vectors are directional rays.
and to solve them you have to find the component form, the direction, and the magnitude.
The component form is when you subtract the terminal point and the initial point.
The magnitude, also known as the length. To solve for that, you have to use the distance formula and you plug in the terminal point and the initial point to solve for it.
The direction is the angle formed with the positive side of the x-axis and your vector when you go counterclockwise. We started down at that house, which is known as the initial point for a vector. Let's say that point is 1, 1.
We ended up here on the top of the hill, which is known as the terminal point, and let's say this is -5, -5. So to find the component form of a vector, you have to subtract your terminal point, which was -5, minus your initial point, which was 1, and that would be your x-coordinate, and then you have to do the same thing for your y-coordinate, so -5 minus 1, and then you solve that, and you get -6, -6, and that's your component form.
To find the magnitude, you need to use the distance formula. And to represent the magnitude, you represent it as your initial point, A, and your terminal point, B. So you type in the distance formula, and you plug in your points. Ours are 1 minus -5, which is +5, squared, plus, and then another 1 minus -5, which is again +5, squared. And next step in the simplification. So 1 plus 5 squared is 36. So 36 plus 36. And that simplifies to the square root of 72. And the last part, you simplify the square root of 72 to 6 root 2. And that is the magnitude of our vector.
So to find a direction of a vector, you need to first put the vector into standard form, which is putting a point at the origin, and then using your component form point and graphing that. And our component form point was -6, -6. And then you connect those 2 points and you get your vector. Now what you need to do, you need to find this whole angle, and that's your direction. So you would need to add 180 to whatever this angle is.
Because you have a 90-degree angle here and a 90-degree angle here. So that is an automatic 180 degrees.
So to find this angle, you need to make a right triangle, and then we know the length of this would be 6, and the length of this would be 6. And then you use SOHCAHTOA, and you get that this angle is 45, and 45 plus 180 is 225 degrees. So that would be the direction of the vector. Now we are going to do vector operations.
There's vector addition, where you add the two vectors. So adding the two x-coordinates, you get A plus C, and for the y-coordinates, you get B plus D.
Now we are going to do subtraction, and for that you just subtract the x-coordinates and the y-coordinates. So you get A minus C and B minus D.
Now we are going to do scalar multiplication. For this, all you need to do is distribute the v to your x and y. So you get VA and you get VB.
Now we are going to look at the parallelogram method for adding vectors. All you do is you just add these two vectors here, and you get this vector in the middle, which is vector 1, -2, and then you connect these, and it forms a parallelogram because they're parallel.
Now we are going to do the triangle method for adding vectors. So I have these two vectors here, and you add them, and you will get a final vector completing this triangle. And this vector is 4, 0. Now we are going to talk about different kinds of vectors. There are equal vectors and there are parallel vectors. Parallel vectors are vectors that have the same direction. So let's say this vector has a direction of 60, and this vector also has a direction of 60. Then these two are parallel vectors. Another type of vectors are equal vectors. Equal vectors are vectors that have the same magnitude and the same direction. So how about this vector has a 30-degree direction and a length or magnitude of 5. And then this vector can also have a 30-degree direction and a length of 5. Then these two vectors are equal. This concludes our lesson on vectors.
Thanks for watching.